to you guys. So in this video I'm going to be introducing you to data analytics, and also I'll be explaining how this term or concept differs from data analysis and the misconception about these two. So before we go into what data analytics is all about, so it is important to break it down into the terms that actually make up this word. So data analytics is made up of data and analytics. So what is data before we now combine it with what is analytics, and then what is data analytics? So introduction to data. Data, as widely known, are unprocessed and organized facts, which includes text, videos, numbers, images, and sounds. So say, for example, you are trying to get names of your new friend. So when you approach them and hey, what is your name? So the name or whatever answer the person gives to you is an information. So if the person say, hi, my name is Wittig, so that person has already produced some sort of information to you, which is a name. And name always comes in form of a text. And in this way, when you ask someone and it is not put down in a written form, then that means it's a sound. So that way you can convert sound to text. So when you want to write down the name of your friend, you put it on paper, then you say Wittig. So this is an example of data. And again, when you record, let's say for example, you went on an hangout or a picnic whatsoever, or you are just hanging out with your friend at random, then you picked out your phone, make some video recordings, and at the end of the day you guys want to see it later. So what you were doing at that point is collecting information about how that event is looking like, or what the moment is like at that particular point in time. So when you get home, you want to view this video again, so that is a data. A data has been recorded. Then later on, you want to view this thing at the end of the day. So when you record the video, there are some things that you may not particularly pay attention to. Say for example, the size of the video, the quality of the video, the orientation of the video. You know, you would have come across something like 460 x 720. Sometimes if you want to play video, the platform where you want to play the video is going to ask you, do you want to play 320p, or you want to play 460, or you want to play 1080p, and so on and so forth. So those are information about the video. Those are data. So how can this data now translate to what can be meaningful? So before we go into how to translate data, there is also, it's also important for us to know that we have two forms by which data can come. So if you have data, data can come in two forms, and the first one is called structured or unstructured data. So when we are talking about, let's start with unstructured data. Let's say for example, you give birth to a new kid. So at the end of the day, this child grows to, let's say, 1 to 2 years. So if this guy wants to, or the little kid wants to express him or herself, if they want to eat, you would have come across something like this before. If a baby is hungry and they want to express themselves, they mostly resort to crying, because at that point, that is the easiest means of communication from them. You as the mother or the father or somebody in charge of the baby may not necessarily be able to interpret the information perfectly. When a child is crying or when the baby is crying, it might not particularly mean that they are hungry. It may mean maybe they want to use the toilet, or maybe they want to urinate, or maybe they are feeling unwell. But at that point, immediately you listen, or when you hear that the baby is crying, the first thing you want to resort to is feeding them. You assume that they are hungry. At that point, the child or the baby is not able to structure the data, structure the information. He or she is not able to pass the right information at that point in time. So if a data is in the form of, when it is raw, when it cannot be particularly transformed, or we cannot get enough insight from it, we call it unstructured data. The data is actually saying something, but we do not understand what it is saying at that particular point in time. So we say the data is unstructured. Then when we now say data is structured, let's say for example, the baby grows to maybe 2 years, 3 years, then at that point, he's able to say, mama, eat, mama, food. You already know that, okay, this is what the baby is trying to say. At that point, the data may not be particularly structured yet. So in that kind of scenario, we can call it a semi-structured data. So when the baby now gets to say 2 years old, 3 years old, then he or she is able to express his or herself and say, "Mommy, I want to eat. Mommy, I want to use the toilet," and so on and so forth. So that way we call it that the data or the information that the child or the baby is trying to pass is now structured. We can understand. We cannot assume at that point anymore, because the information or whatever we are getting from the child can be interpreted easily. So just like the presentation on the screen says that unstructured data has little to no meaning. So when it comes to unstructured data, they basically have little to no meaning. Just like I've explained before, that's going to be crying for for help. He or she doesn't know how to say it perfectly, but definitely is trying to say something. So unstructured data has little to no meaning at all. Then when it comes to structured data, so structured data is derived from observation or measurement. So most of the time when you have data that is going to be structured, you are in a classroom and then you discover that there is a particular child that is intelligent. So you may not necessarily have gotten information about the child, but based on your observation, when they ask question, he's already raising his or her hand up, answering questions, contributing his or her opinion. So that way, from observation, you can tell that, hey, this person is actually brilliant or intelligent. Also, it can be from measurement. When we say measurement, something that you can quantify. Say, for example, you actually put this kid, you put him or her on a test. Then after that, you now discover that, oh, truly, this person is smart, because out of 20 questions, he got everything right. So that way, we can say the data can be measured. So data structure or structured data can come in two ways. It can come from observation and it can come from measurement, or both. Also, when data is processed, when it becomes information that we can read, use, or write. Data are unprocessed and organized facts, which includes those formats that we've already explained before: text, videos, numbers, images, and sound. Then we have something that we call database. So before we understand, or before we go into what is data analytics or data analysis, we need to understand some concepts around data itself. So when we say database, a database is a collection of data. It is known as where data is contained or stored. It is a system of storing, accessing, and manipulating data. So let's say, for example, you are a business owner, and then you have a warehouse where you're selling provision, drinks, and so on and so forth. So when you get your goods from your suppliers, the next thing that you want to do is put them in your warehouse until there is demand to get all of those stuff. So you getting the data, collecting the data, yes, you're collecting your goods from your supplier is called data collection. You are collecting the data, and because you are not interested, or you may not necessarily have any use case of that data at that point in time, then you can store it in your warehouse. So data warehouse is where you collect your data and store them until the time they are going to be needed. Then we said a database is an organized collection of structured information or data, typically stored electronically in computer system. So most of the database that we have are usually stored electronically. And also, so sometimes you may have them stored in an offline mode. So you can save your data and then put it on flash drive, for example. You can save your data and put it on your phone, send it to your phone. So your phone and the flash drive are not necessarily a database, because that is not what they are meant to, but you are saving your data on them temporarily, because that is not what they are designed to do or to handle. But we have database tools that are solely the primary source, or their primary purpose, is to manage and store data, also to make sure that they are organized as as clean as possible. Then we have so on this, then we have the next part we are going to be looking at. So we have introduction to data analytics itself now. So what we have been dealing with prior to this part is trying to introduce ourselves to the concept of data. Now, what is data analytics? We have data. You already understand what data is: collection of information. When you have information at all, that is data. Now, when we now merge it together with analytics, then that means we are trying to get some information about that data. Data analytics is the collection, transformation, organization of data in order to draw conclusions, make predictions, and drive informed decision. So you would notice that the explanation or the definition of data analytics has already combined everything that has to do with data. So from the moment where you collect your data and draw conclusion, to making prediction and drive informed decision, that is every single thing that data is all about. So you collect it, you transform it, you organize it so that you can draw conclusions, prediction, and informed decision. Now let us try and break it down to the nearest meaning so that we can understand to layman. Data analytics is often confused with data analysis, and this is one of the concepts that usually confuses the newbies. So anybody that is new to data analytics, that they're just starting to learn, they get this term very confusing because they believe that data analytics might actually be the same thing as data analysis. But while these terms are related, they are not exactly the same. Because in fact, data analysis is a subcategory of data analytics that deals specifically with extracting meaning from data. So when it comes to data analysis deals with past events, something that has happened. You are a business owner, then you want to investigate how much have you made maybe in the last couple of years. So the data needs to be available. The data needs to be collected. You would have collected the data. The data will be available already before you can do analysis on it. So data analysis depends on past events, something that has happened. Then when it comes to data science actually deals with using data to theorize or forecast. That is basically predicting. So you want to know what will happen to your business in the next 5 years. That is the concept of data science. You're trying to forecast, you're trying to predict, you're trying to know what has not happened. You want to predict what might likely happen in the nearest future. Don't forget, data analysis is going to investigate what has happened. Data science is going to predict what will happen. Then we have data engineering, which is basically just about building system or pipelines. That is where is going to, the flow of your data from the source to where you are making decision or where you are doing your analysis. So how will the data be stored? And then from the storage, how will it get to where you want to analyze it? Then from there, how will it get to your stakeholders? So basically, what data engineering is going to be doing is to build pipelines or creating flows of how your data is going to move from one stage to another. Then we said that data analytics is a multidisciplinary field that employs a wide range of analysis techniques, including math, statistics, and computer science, to draw insight from data set. So just like I've always explained, that you cannot hate mathematics and statistics and want to do data analysis. You have to settle down for, your hatred for mathematics and statistics needs to be lowered at least to a very reasonable extent. So mathematics and statistics are very important concepts as far as data analytics is concerned. So data analytics is important across many industries, business owners, business leaders, everybody. We have to analyze our data. So when it comes to data analytics, if you are not analyzing your data, then you want to predict what is going to happen to your business in the next couple of years, and so on and so forth. So just like I've stated here, a sneaker manufacturer might look at sales data to determine which designs to continue or which one to retire. So you are a business person, you invest in a lot of product. Then at the end of the day, you want to know which of your products is not doing fine, which of them is doing fine, which of them should you invest more on, and then which one should you actually take out of the market. So when it comes to data analytics, this is the very simple concept as far as data analytics is concerned. So now, and what data analytics is all about, then we should try and limit ourselves to data analysis. What is data analysis? Data analysis is the process of cleaning, changing, processing data, and extracting actionable and relevant information that helps business make informed decisions. So in this case, it is not only business, it can be your health, it can be a lot of things. So data analysis has wide range of use case. Also, We have data management, which requires the database to contain, manage, provide access to information gathered through mining. So when we say mining, that is gathering data, just like the literal meaning of mining. You source around and get data that is going to be used for your business decision. And then one of the most popular management tool that we have is SQL Server. And SQL Server is a tool that is used to store data. But before we can make use of a tool, then there has to be something that we have to communicate with the database itself, which is called SQL. SQL is structured query language. SQL is a language and not a tool. When we say SQL, it means a means by which you can use to communicate with your database. Say for example, English is a language, and then English is spoken in a lot of countries. We speak English in Nigeria, in Ghana, in the United States, in the United Kingdom, Canada, and so on and so forth. So English is not a country. English is a language. Exactly the same thing when it comes to SQL. SQL is a language and not a tool. That means SQL can be written in a lot of platforms. Example is SQL Server. We have BigQuery, we have Oracle, we have MySQL, we have PostgreSQL. Let us see all those tools as countries where SQL can be spoken. And SQL was created in 1979, and it is still one of the most widely used language when it comes to data. We also have a term called data presentation. We also have data mining, which involves gathering data and information across different sources. So all these terms are very important as far as our data analysis journey is concerned. Also, we have types of data analytics. So when we are discussing about the types of data analytics, it means the various concepts by which or of which data analytics actually covers. Don't forget, in the previous slides, we discussed that data analytics is like umbrella term that covers data analysis, data science, and data engineering. So that means all these three actually are under data analytics. So one of the confusion that people usually have is that, is data analysis the same thing as data analytics? And at the end of the day, when you ask them to give you the types of data analytics, they end up explaining data science as a subtype or as a subcategory of data analytics. So you should not get them confused. Data analytics is not the same thing as data analysis. And data analysis is a subcategory or is a branch under data analytics. Now, we have 4 key types of data analytics, and the first one we're going to be looking at is called descriptive analysis. So when we say descriptive analysis, it is basically, literally the way descriptive sounds. Describe this data. What can we know about this data? What information is this data trying to pass through or to us? What can we deduce from this data? What are the insights as far as this data is concerned? That is descriptive analytics. It's going to basically tell you what happened. Then the next one here is diagnostic. From the way it sounds, diagnose. We want to know why something happened. Why did this thing happen? So that means before you can diagnose, that thing must have happened. That is what data analysis, or that is where data analysis comes in. Don't forget, we said data analysis always work with past events. What has happened? So when we are trying to describe our data and also trying to diagnose what has happened to our data, basically we are doing data analysis. Then when it comes to predictive analytics is basically saying that, okay, from the way it sounds, predict what will likely happen in the future. Don't forget, we said the other time that data science also depends or solely work with what will happen, predict what is going to happen in the future. Also, prescriptive is like prescribing. Somebody is sick, you diagnose them, then you want to predict that, okay, in the next 5 days, if you use this drug that I'm going to be prescribing to you, then you should be fine. That is all, as far as data analytics is concerned, that is all the concept under it. Describe, diagnose, predict, prescribe. So now, who is using data analytics? What are the which of the sectors, as far as the industries are concerned, who exactly is using data analytics? So it depends on how you want to apply your data analytics skill, or how you want to make use of this skill. So we said that data analytics has been adopted by several sectors, and such as travel and hospitality, healthcare, business, retail industry, and so on and so forth. So in summary, to save ourselves the time for talking and all of that, so we said data analytics help individuals and organizations make sure of the data in a world that is increasingly becoming reliant on information and gathering statistics. A set of raw numbers can be transformed using a variety of tools and techniques, resulting in informative, educational insight and that drive decision making and thoughtful management. So now, this is more detailed explanation on what data analytics is all about. So remember, we said descriptive analytics is a type of data analytics, and this describes what has happened over a given period of time. For example, have the number of views gone up? Are sales stronger than last month? So you are basically trying to work on what has happened. So you have the data for last month, you have the data for this month. Then you want to compare what exactly happened between last month and this month. Is it better this month, or was it better last month? We also have for the diagnostic analytics. So this focuses more on why something happened. So it involves more diverse data input and a bit of hypothesizing. Did the weather affect beer sales? Did that last marketing campaign impact sales? So you are into business, you try to do some ads, then you want to confirm if the ads that you've done actually have any effect or impact on your business. Then we also have predictive analytics. So this involves using historical data to make prediction. So you move from one place to another, you're going from your place to your workplace, then you spent 1,000, for example, as the transport fare. So this is your first day in business, at that workplace. So moving from your place to the workplace, you realize that you spent 1,000. So tomorrow, by default, you would have already predicted how much you are going to spend. Or let's say, for example, you spend 20,000 monthly on food, on feeding. Then when everything got expensive, maybe through inflation or economic disruption, then you now try to predict that now that everything is expensive, let me add more to how much I'm going to be spending on feeding. That is predicting based on what has happened. Also, we have the prescriptive, which we've already explained. Prescribe. Now that this thing has happened, then what should we do? You're trying to act on the data that you have on ground. So moving from there, we now have the data analytics tool. So data analysts have a broad range of software to help acquire data, store information, process data, and report findings. Data analytics has always had a loose end to spreadsheets, as far as most especially Microsoft Excel. Data analysts also often interact with raw programming language to transform and manipulate databases. An example is structured query language. Structured query language arguably is a programming language that is commonly used for database. I use arguably because some people believe that SQL is not a programming language. But when you work with SQL to some extent, you realize that it can actually pick up some programming tasks and do it. So if SQL can actually do some programming tasks, then that means it actually ticks up some ability to program. So we can assume, or we can conclude, that SQL can also be tagged as a programming language. Also, we have spreadsheet tool. An example of a spreadsheet is Microsoft Excel. We also have Google Sheets. We have a lot of them. Also, we have data visualization tool. So data visualization tool is basically BI tool, business intelligence tool, that we can use to visualize what we found out about our data, basically building charts and graphs. We also have machine learning. We have SPSS. SPSS is also a spreadsheet tool. So machine learning falls under statistical programming language. That is the R and Python. They are also called the programming languages. Those are the most common or the most popular programming language in data. So your R, your Python are most used when we are trying to work with advanced data analysis. And machine learning also falls under them. Now we have the phases for data analytics, or we can say data analysis. So when you say data analysis phases, or when you say data analytics phases, you are also saying the same thing, because we have already said that data analysis is a subset of data analytics. So that means data analytics covers everything under data analysis. So according to Google, there are 6 phases of data analysis. We have the ask, prepare, process, analyze, share, and act. So the first phase is the ask. You must always understand the problem. Without a problem, then you should not look for a solution. There is no reason why you have to look for a solution if there isn't a problem. So you should always ask and confirm what exactly is the problem. So we have an example here from Albert Einstein. He said, if I had an hour to solve a problem, I would spend 55 minutes thinking about the problem and 5 minutes thinking about the solution. So when you understand the problem, when you understand the problem that you are passing through, then to get or source for the solution may become a lot easier. So as a data analyst, the first phase of your data journey is always to ask. Don't feel shy to ask. Don't feel inferior to ask. Maybe you think if you are asking, then they may think you don't know what you're doing. That is not the point. So when you ask, you have clarification and you'll be able to understand your data or whatever you are doing better. Also, we have the prepare. That's the second phase. So prepare is basically, what do I need? So when you realize your problem, you've already identified the problem, then basically the next thing that you want to find out is, what do you need to solve the problem? What are the materials that you need to to be taken into account? So what factors, what problem, what type of a solution do you need to tackle this problem? Also, we have the process. So process is basically the moment you want to start saying, okay, I already know what I need to do. Now, let me do it. How do I start? What do I need to start? You already have what you need to start, which is the prepare. Then the next thing now is what you have already gotten. How can you use it? How can you utilize it? Making it usable. So utilizing this particular thing to solve this particular problem, this is the third phase of data analysis. Then we have the analyze. So when you've already gotten what you need and then you understood what the process is going to be like, then the next thing for you to do is now start doing it. So that is the analyze part. You analyze your data. Then at the end of the day, you share. So you've already gotten the solution to your problem. And the next thing for you to do is to get reviews. So what is somebody saying about this solution that you've provided? What is the other person saying about the solution you've provided? And so on and so forth. Then we have the last stage, which is the act. Now that you know the problem, now you should solve it. So people have already given you their verdict that, okay, I think this is a good thing. This is nice. This is not bad. You've already gotten what you needed. You already understand how you're going to go about it. Then the next thing for you to do is to solve it. So now this is basically what data analytics is all about. So this is basically the breakdown of the concept that surrounds data and data analytics, as well as data analysis, data science, and data engineering. I'm going to be dropping the presentation file in the link. So there's going to be a Google Drive link that's going to direct you to where you can download the presentation, so that in case you want to have a good read as far as this slide is concerned, then you can go ahead and do that. So don't forget to share, like, also subscribe to my YouTube channel, repost and share, and invite your friends. Thank you very much, and look forward to my video on my introduction to Microsoft Excel. Thank you.